This video is a case study of our 26-68-inch fishbone activity that we've had up here at the RT Scissors plant. I'm standing down here on the floor right in the middle of our physical fishbone. The way that this activity really started was initially we drew out in words what the actual steps were to build a 26-68-inch scissor lift. We then took it to the next step and did it with pictures, with sketches, pictures, and drawings out of our parts manuals. The last step was to take it down to the floor and actually do it with an actual unit. What this activity has done for us is we're able to see all of the different components that it takes to build a scissor lift and look at them in really a different light. We look at the big pieces, and then right behind the big piece are all of the subcomponents that make that big piece. And then on the main line, those big sub-assemblies are attached to the unit. What this activity has done for us is really made us realize how much quicker we think we'll be able to build scissor lifts. Initially, we didn't think we would be able to build 20 per shift. And through this exercise and this activity, we're very confident that we can build 20 per shift and actually do it with less people than we originally thought. The key to the fishbone too is that the velocity through the main line we feel will be much, much greater than before. And then just overall, the key learnings from this activity have been incredible. We've really looked at the unit in a much simpler way, and I'd like to just use the analogy of eating an elephant. We've chopped up the elephant into little pieces, and now it looks much easier to do.
What you're looking at here is the physical layout of the product fishbone for the RT68 scissors. Right down the middle of the fishbone you see what we consider our main assembly line, stations M1 through M4. That's what we're considering the backbone of this product fishbone. Off to the side of each one of these stations you'll see major assemblies staged. That's what we feel are going to be the modular components that will be installed on our main line in the particular positions that you see here. Behind each major subassembly, you'll see the detailed parts or subassemblies that feed the subassemblies. So the main product will progressively be built from station M1 through station M4, which is our final installation position, where we'll bring on our link set and we'll also bring on our platform. This was a result of a product teardown exercise that was performed by the 68 assembly team in preparation for ramping up production and building 7 to 20 units a day. What I'd like to do now is briefly explain the teardown process that we used in tearing apart the 68 scissor and laying out our product fishbone in preparation for production. The first step that we took was to tear apart a completed unit. In doing that, what we wanted to do was to identify what are the major subassemblies that we want to be installing on the main line, and also to understand the hardware required. One of our goals of this was to simplify the backbone of the main assembly line as much as possible. The second step that we performed was to put that unit back together using the large subassemblies that we pulled apart. From that, we wanted to gain what was our potential build sequences, what are our rough installation cycle times, and what are some potential jigs and fixtures or installation devices that we can use to take these assemblies onto the main line with a one-shot installation with no adjustment. The third step we did was take those major subassemblies and tear those apart. With that, we wanted to identify subassemblies to the subassemblies, what types of parts are required, and what tools are required to assemble our feeder lines. In that, we also wanted to identify what kind of jigs and fixtures we could use to make our subassemblies a hands-free operation and to increase the efficiency of that operation. The fourth was to build our major subassemblies. What we did when we did that was actually get down into a level of detail greater than we had done before, and actually documented each process step and the work sequence to accomplish that. What are the tools required? And at this point in time, we wanted to identify what our real quality characteristics were to build this unit in a first time, first pass, high quality build. Also, at this point, what type of tabletop fixtures and things can we do to hold the device to free our operators to be more productive? Many of the things we considered during our teardown process were what were the biggest chunks that we could take off of a fully completed unit. What are the safety issues? Installation hardware required, the ergonomics of the work. Those are all major considerations that we considered while we were building this. After completing our teardown exercise, our goal was to have clearly identified what our sub-assemblies were. What are they and where do they go on, in what workstations? Then we created our physical fishbone layout that you saw previously in the video. What is our installation sequence? What are the major sub-assemblies? And we physically staged them along the line. What were the sub-assemblies that fed those? And then the detailed parts of it. At this point in time, the way we've got it built now, there are about 32 major fasteners that go on the main assembly line. Everything else has been broken back into a feeder line. What we did with that information and what we're doing now is we're progressively working through each sub-assembly using either a production preparation or a Kaizen event in designing the workstation and the workflow for each sub-assembly. Things that we're looking at putting together are the work sequence, what are the detailed cycle times and how do they compare to the tack time in preparation of determining how many team members we need in order to meet our tack time. One of the most important pieces is the jigs and fixtures. And what is it that we can do to make the work easy and ergonomic and productive? And our quality characteristics so that when we build a sub-assembly that it installs correctly the first time. Things that we are considering while we run these Kaizen events are flow, safety. We're building for a 27-minute tack time. All our installations on the main line, we're looking to be one-shot installations with no adjustment. In our sub-assembly fixtures, we're looking to have Poka-yoke devices that don't allow us to make a mistake. We don't want any alignment and adjustment on the line, and we want no cranes or forklifts in production. We have a ground rule that we're going to be building on a moving assembly line, and we're looking to build correct ergonomics into the work and into the workstations. We want no manual lifting, no hoists, and no crane, and quality built in from the beginning.
One of the sub-assemblies that we took into account for our event the week of February 7th with Mr. Nagamatsu was the hub assemblies for the RT68 assembly. As you can see here, feeding the main line is our rear hub assembly. You've got your brake motor, your hub, and then your tire assembly. And the way this is going to feed in is we're going to come back here and we're going to build up our brake motor. You're going to put your hydraulic fittings on. That in turn mounts into the hub assembly with the hydraulic hose, and then that will mount onto the chassis. When the hub assembly is mounted to the chassis, the tire then comes on with the 6 lug nuts that put the chassis onto the main unit. As you can see, that process will be repeated on either side of the chassis. You got a left and right on the front, and you've got a left and right on the rear. One of the installation tools that we designed and built during the event was for our rear hub assembly. As you can see here, the brake motor is assembled in the saddle. The fittings are put on while you're held down in location. And then as that brake motor is completed, the pin is released, slid forward, self-aligns and locates itself into the hub assembly, at which point the 4 bolts are put in, still on your on your assembly tool, line side, and then upon installation, the cart slides in. It's got self-aligning flanges here that'll help you guide in, align your 4 holes, which in turn you put the 6 bolt holes into the chassis, and that hub assembly is installed.